All right, welcome everyone. Today we're diving deep into something that's totally changing the game in analytical labs.
You got it. Automation. We're going to break down how robotics, AI, you name it, are changing how labs do those everyday analyses, but also those really complex ones.
Yeah, and it's happening now, not just some sci-fi future thing. We're talking about things like prepping samples automatically, figuring out the best way to schedule those expensive lab instruments so they're not sitting around, and how all that data is being analyzed automatically in some really cool ways.
And for you, the listener, it's not just the technology that's cool, it's the real world impact.
Yeah.
We're going to be looking at the challenges of actually making these systems work in a lab. And the big question is it really worth it? The return on investment.
Exactly. We want to look beyond just the idea and see how labs are using this stuff to get through more samples, reduce those little human mistakes that can happen, and even do a ton of testing without needing someone watching it all the time.
And this whole shift, it's happening for a reason. Things are getting super complex, like in pharmaceutical research, and there are more and more rules to follow. So automation is becoming super important for labs across a bunch of fields. Not just nice to have, but gotta have it.
Okay, let's break this down, starting at the beginning.
Yeah.
Getting samples ready for analysis. I mean, that can be a lot of work. How is automation changing that?
Yeah, and what's interesting is how much it streamlines those very first steps. I mean, think about it, all that careful measuring, mixing, transferring. Automation really cuts down on all that, and when you do that, less risk of human error.
Makes sense, especially when you think about high throughput screening in drug discovery, right?
Yeah.
You're talking tons of compounds.
Oh, yeah, it's huge. So to find new drugs, they test thousands of compounds, and automated sample prep is key. Like take human liver microsomes, HLMs. It's basically using these tiny parts of the liver in a test tube.
Like a mini liver to see how it breaks down a drug.
Yeah, exactly. And the research says these HLM assays are great for high throughput screening and the gold standard to predict how a drug is metabolized by the liver. This means finding promising drug candidates way faster.
Wow. So these systems can run tests on tons of compounds at once.
Yeah. They measure how fast the drug disappears in the microsomes, rank them based on stability, and then bam, the research team knows which candidates to focus on.
Makes sense. And the research mentioned other systems like using hepatocytes or even liver slices. How did those fit into this whole automated sample prep thing?
That's a good question. Microsomes are great for a first look, but they don't always show everything, especially with phase 2
Ways
metabolism.
of two.
Right.
Yeah.
So that's when the body attaches other molecules to the drug, changing how it works and how fast it's cleared. Now, isolated hepatocytes, which are liver cells that have been separated, they give a better picture because they have a wider variety of enzymes. And some of those can even be frozen, cryopreserved. Then there are liver slices, keeping more of the liver structure. Yeah. And the cool thing is, both of those, the hepatocytes and liver slices, can be used in automated setups. So you get a more complete metabolic profile of a drug.
So you could have different automated platforms for different levels of analysis,
Yeah.
depending on where the drug is in development.
Exactly. As things move along, you need more specific info. The research also talks about CYP reaction phenotyping. So these are enzymes in the liver that break down lots of drugs.
Okay.
Knowing which CYPs are involved helps predict drug interactions and how genetic differences might affect things. And guess what? Automation helps get that data too.
Wow. So it's not just speed, it's getting a more in-depth analysis earlier on. Really cool. Okay, let's move from sample prep to the actual analysis, those high-tech instruments. How does automation help with instrument scheduling?
Yeah. So analytical instruments, those mass spectrometers or NMR machines, they're not cheap. And scheduling systems can help make the most of them so they're running as much as possible, minimizing downtime.
So instead of someone manually scheduling, hoping everything fits, the software does it all.
Right. Takes into account what's available, the analysis needed, can even prioritize urgent stuff. Huge help for labs that have tons of samples or strict deadlines, all about maximizing output and getting those results back fast.
Really streamlines things. Now, with all these instruments going, you get a ton of data, right? What about processing all that? How does automation help there?
Oh, it's essential. Modern instruments produce massive data sets. Analyzing all that by hand would take forever and be prone to errors. This is where specialized software and AI are stepping in.
The research even talked about AI in radiology, helping analyze medical images. Interesting comparison. How does that connect to what's happening in analytical labs?
It's a good parallel. Like, AI is used to understand images, create reports, even offer insights to doctors. In labs, AI algorithms can be trained to analyze complex outputs from things like mass spectrometers or NMRs. Think of it as a super smart assistant who can spot things we might miss.
Wow.
Yeah, they can identify substances, measure amounts, flag anything weird in the data.
So it's not just crunching numbers, it's about finding the important stuff in all that data.
Absolutely. And AI can find those subtle patterns or anomalies we might miss. Huge for quality control or research. The research also talked about specific applications like nanoelectrospray, mass spectrometry, and high throughput mass spectrometry.
So AI is moving beyond just images. It's becoming a powerful tool to analyze complex data in all sorts of fields. But implementing all this can't be easy. What are some of the challenges labs face?
Well, the cost of the equipment and software can be pretty steep, especially for smaller labs.
And it's not just buying it, right? You need people who know how to use this stuff.
Exactly. Training is key. Scientists and technicians need to know how to run it, fix problems, and understand the data.
Hmm.
That might mean more training or even hiring people with expertise.
And what about making all these new systems work with what a lab already has? That seems tricky.
Oh, yeah. Integration can be tough. Labs often have a mix of old and new equipment. Getting them to communicate smoothly can be complex. Might involve upgrading IT systems or even creating custom software.
So you've got cost, training, and integration challenges. Labs really have to think about all that. And of course, the big question is, what's the return on investment? The ROI.
So the ROI comes in a few ways. Increased throughput is a big one. Automation means processing more samples faster, which means quicker results. For businesses, that's more revenue. And in research, it speeds up discoveries.
And less human error. That's got to factor in.
Definitely. Automating steps reduces those manual errors in handling and data entry. That means better data quality, and you don't have to waste time and money reanalyzing things.
Also seems like it could free up scientists and technicians from those repetitive tasks.
Right. It frees them up to focus on the complex stuff, the thinking, the designing, the interpreting. That can boost productivity and innovation in a lab. Like, the research talked about how important fast and reliable data is for high throughput screening and drug discovery. Automation makes that happen and ultimately impacts drug development.
Okay, so it's not just saving money. It's about using your people in the best way possible.
Yeah.
Now, can we look at some examples of how automation is actually benefiting different labs?
Sure. Imagine a pharmaceutical lab using automated liquid handling with mass spectrometry, like we talked about with HLM and hepatocyte assays. This setup would let them screen way more potential drugs for stability way faster. They get good data quickly, and it speeds up the whole discovery process.
It's a big speed boost. What about an example of reducing human error?
Take a quality control lab in a factory. They could use robots to automatically take product samples and load them into instruments for testing. Less manual handling, less chance of mix-ups or contamination.
So the results are more reliable.
Exactly, which is crucial for safety and regulations. Now, how about an example with AI and complex data? Think of a research lab studying how a molecule's structure affects its activity, for drug development. They often use NMR spectroscopy, and AI software could analyze that complex data automatically. The software could even pinpoint structural features linked to biological activity.
That'd really speed up drug development, finding what works best.
Right. And lastly, high volume testing with minimal human oversight. Imagine a clinical lab processing thousands of patient samples daily. Automating everything, from receiving samples to analysis and reports, ensures fast, accurate results, even with tons of samples.
Those examples really show how powerful automation can be. Yeah. So as we wrap up, what are the key takeaways?
Automation offers a big increase in how much a lab can do, a big reduction in errors, and the ability to handle huge amounts of testing without needing as much direct supervision.
And while there are those initial challenges like cost and training, it seems like the ROI is definitely there.
Yeah, increased efficiency, better data, and it lets those skilled analysts focus on the important stuff.
So here's something to think about. As automation keeps growing in labs, how will the role of the scientist change? What new skills will be needed? What will this mean for scientific discoveries and quality control down the road? It's a really exciting time for labs.